Welcome to Mr. Vaughn's classroom. Please take a moment, hit the subscribe button so that you get notifications anytime I post a new video. And if you enjoy this content, please give this video a thumbs up so that other people can find the same help that you have found. Today we're looking at Unit 4 on functions, Lesson 3, interpreting and using function notation. Our learning goal today is to use function notation to talk about functions. We have 3 learning targets. As we go through these practice problems, these are 3 things you should keep in the front of your mind. By the end of the lesson, you should feel comfortable making these 3 statements. And if you don't, please ask for further clarification. If you're in my class, simply use class time to ask for those help. But if you're watching this online, go ahead and drop a comment, and I'll get back to you with any clarification I can offer. Our first learning target: I can describe the connections between a statement in function notation and the graph of the function. Learning target number 2, I can use function notation to efficiently represent a relationship between 2 quantities in a situation. And learning target number 3, I can use statements in function notation to sketch a graph of a function. Our glossary terms begin with dependent variable, a variable representing the output of a function. We call it the dependent variable because it is a calculation that is dependent upon what you choose to put in as the input. So because the value depends on something else, it is the dependent variable. Next glossary term is function. A function takes inputs from one set and assigns them to outputs from another set, assigning exactly one output to each input. And that is the important thing to notice. Every unique input is going to have exactly one and only one unique output if it is a function. Our next glossary term is function notation. Function notation is a way of writing the outputs of a function that you have given a name to. If the function is named f and x is an input, then f of x denotes the corresponding output. So think of f of x as y. Our next glossary term is independent variable, a variable representing the input of a function. So your independent variable is your input. That is your x. That is what you are able to change and use to calculate your output. So independent variable is what's going in for x. That is your input, and you can control what that value is. Now we can begin the practice problems for Unit 4, Lesson 3. Function f gives the temperature in degrees Celsius T hours after midnight. Choose the equation that represents the statement at 1:30 p.m. the temperature was 20 degrees Celsius. So some key words that we want to notice here. Function f gives. anytime you see this, function gives, you have your output using the input. They will always word it this way. So that means our output is temperature in degrees Celsius. And that means our input is hours after midnight. Now, if you remember, function notation is written name, input, in parentheses, equals output. So if we want to fill this in, we know that the name of the function was f. We know that the input is hours after midnight. So if we're talking about 1:30 p.m., that is 1:30 in the afternoon. So that is 13 and a half hours after midnight. So 13.5. And we know that our output is the temperature in degrees Celsius, and they're telling us it was 20 degrees. So we have F of 13.5 equals 20, and we can see right here, this matches choice D. If we try to look at the others, we can see that A is wrong because they input the time instead of making that time the number of hours after midnight. We can see that B is wrong because 1:30 p.m. is not 1.5 hours after midnight. It's 1.5 hours after noon. It's 13.5 hours after midnight. And then C is wrong because they used the military time instead of turning the time into the number of hours after midnight. So D is the only one that correctly models this situation. If you have any questions about how to take a statement and turn it into function notation, please ask for help. If you're in my class, simply use class time to ask for that clarification. If you're watching this online from somewhere else, go ahead and leave a comment. I'll get back to you with any clarification I can offer. That way you're set up for success. Our next practice problem, Tyler filled up his bathtub, took a bath, and then drained the tub. The function B gives the depth of the water in inches t minutes after Tyler began to fill the tub. Explain the meaning of each statement in this situation. So, I need you to remember function gives output using input. That means my output is depth of water in inches. It means my input is minutes after Tyler began to fill the tub. So minutes filling, or I should say after minutes after beginning to fill the tub. So, anytime I have function notation here, remember it is name, input equals output. In this case, that is B of minutes equals inches. Now I can begin explaining what each of these means. So number one, the 0 in parentheses is minutes. The 0 that it equals is inches of water. So there was no water after 0 minutes. So the tub was empty when he began filling it. Number 2. I've got 1 in parentheses, so that's going to be 1 minute, is less than the 7 in parentheses, which is minutes. But remember, the function is giving us the depth of the water. So this means the depth of the water after 1 minute was less than the depth of the water after 7 minutes. Number 3, we have B of 9 equals 11. So the 9 represents the number of minutes. The 11 represents the inches of water. So we would say after 9 minutes, there was 11 inches of water in the tub. Number 4. We have B of 10, which means the depth of the water after 10 minutes. And we have B of 22, which means the depth of water after 22 minutes. So we could say the water depth was the same after 10 minutes and after 22 minutes. And finally, number 5, we have B of 20, which means the water depth after 20 minutes is greater than B of 40, which means the water depth after 40 minutes. So, the water was deeper after 20 minutes than after 40 minutes. If you have any questions about how to take a description and use it to make statements about function notations, please ask for some help. Again, if you're in class with me, simply use our class time to make sure you get the right clarification that you need. And as always, if you're watching this from somewhere else, please go ahead and leave a comment, ask for help, and I'll be more than happy to give you clarification. Our next practice problem, function f gives the temperature in degrees Celsius t hours after midnight. So again, function gives output using input. So here, my output is temperature. And my input is hours after midnight. Also, remember that when we write function notation, it's going to be name, input, equals output. So with that in mind, number 1, we want the temperature at 12 p.m. So the temperature is my output. They're not telling me what it is, so all I can do is have the name and the hours after midnight. So for number 1, the name is lowercase f, and 12 p.m. is going to be 12 hours after midnight. It's noon. So f of 12. This represents the temperature at 12 p.m. when we don't know the actual temperature. Number 2. The temperature was the same at 9 a.m., and at 4 p.m. So again, we don't actually know a number for the temperature. So what we can do is say function, lowercase f, of 9 a.m. is 9 hours after midnight. And when we see it say same, that means equal to function f of 4 p.m., which is 16 hours after midnight. So f of 9 equals f of 16. Number 3. It was warmer at 9 a.m. than at 6 a.m. So again, 9 a.m. is 9 hours after midnight. So that is f of 9. We see that it says warmer, so that would be greater than. And our other time is going to be 6 a.m., so that is 6 hours after midnight. And the last one, number 4, sometime, we don't know when, after midnight, the temperature was 24 degrees Celsius. So this time it's the input that we don't know. And we generally denote the input as x. So we can say the function f of x equals 24. If you have any questions about how to take a statement and turn it into function notation, please ask for help. If you're in my class, simply ask me for help during class time. If you're watching this online from somewhere else, please drop a comment, and I will be more than happy to get back with you and offer some clarification. Our next practice problem, select all points that are on the graph of f if we know that f of 2 equals negative 4 and f of 5 equals 3.4. So, remember that in function notation, it's name, in parentheses, you have the input, and it equals the output. So here we know that the name of the function is f. We know that our input is x. And we know that our output is y. So in this case, 2 is x, and negative 4 is y. In the next one, 5 is x, and 3.4 is y. Anytime we write a point pair, it's in alphabetical order. X, y. So, I know that one of my points is going to be 2, comma, negative 4, and I know the other one is going to be 5, comma, 3.4. So that means one of our answers is B, and another answer is D. A is wrong because it reversed the x and the y. C is wrong because it reversed the x and the y. And E is wrong because it used the x from the first function as the x and the x from the second function as the y. If you have any questions about how to take function notation and identify the points, please ask for further clarification, whether that's during class time or dropping a comment to ask for help. Our last practice problem: write 3 statements that are true about this situation. Use function notation. Function f gives the distance of a dog from a post in feet as a function of time, t, in seconds, since its owner left. Use the equal sign in at least one statement and the less than sign in another statement. So, we know that function notation is name, in parentheses, input equals output. And we know by looking at the graph, our input is time in seconds, and we know that the output is distance from post in feet. So, we want to come up with 3 statements that could be true, or that are true. Use the equal sign for one of them. So we want to find 2 points that look like they're equal. And what I'm noticing is this point right here when time is 20, and this point right here when time is 40. They appear to be the same, so I'm going to say f of 20 equals f of 40, because the function at 20 seconds is the same as the function at 40 seconds. Next, they want us to use the less than sign. Well, I'm going to look at these points that they already made for us in black when the time is 0 and when the time is 60 seconds. So I'm going to say f of 0 is less than f of 60, because the distance from the pole was less at the beginning than it was after 60 seconds. And our last statement, I want to find one where I can use the greater than. So I'm going to look at this point when the time is 160 seconds, and I'm going to look at this point when time is 100 seconds. And I'm going to say the function after 160 seconds is greater than the function after 100 seconds, because the distance after 160 seconds is bigger than the distance after 100 seconds. If you have any questions about how to take a graph and a description and turn them into function notation statements using equal than, less than, or greater than. Or if you have any questions about anything we went over today with function notation, please ask for help, whether that's during class or by dropping a comment. I promise I will do everything I can to help you out. If you found this video helpful, please hit the subscribe button so you get notifications when I put out new videos in the future. And please give this video a thumbs up so that it helps other people find this helpful content. I look forward to seeing you in the next lesson.